Welcome to GMAT Math Online Math Prep videos. In this GMAT Math Online video, we give examples of advanced equation problems. Skills for solving equations can be applied in more complex, non-standard situations. Here are some examples. Problem. Suppose xy equals 225, and adding 11 to 4y, we get x. If x is negative, what is y? And here are some possible answers. Let's find the solution. X equals 11 plus 4y, so 11 plus 4y times y equals 225. 11y plus 4y squared equals 225, and thus 4y squared plus 11y minus 225 equals 0. To factor this quadratic, we need to look at the factors of 225. 225 equals 15 times 15, and that equals 3 squared times 5 squared. We also have to consider that the first term has a coefficient of 4. Using these factors of 225, we need to find two products, one positive and one negative, whose sum is 11. We also need a product that equals minus 225. We can get these by multiplying 4 times 9 to get 36, and 1 times minus 25 to get minus 25. Also, 9 times minus 25 equals minus 225. This gives us the factorization of the quadratic. 4y minus 25 times y plus 9 equals 0. And from this we have two roots for y. Y equals 25 over 4, and y equals minus 9. Since x is negative and xy equals 225, then y must be negative also. Therefore, we choose the root y equals minus 9. Since xy equals 225, then x equals minus 25. Also, 4y plus 11 equals 4 times minus 9 plus 11, which equals minus 36 plus 11, and that equals minus 25, which is x. Thus, these values are consistent with the original equations and the requirement that x be less than 0. So the correct answer is B. Problem. Y squared plus 2 over y minus x over y equals 3, and y is not equal to 0. Solve for x in terms of y. And here are some possible answers. Let's find the solution. This is a standard algebra quadratic equation problem, except it is expressed in terms of y, and we have a second variable, x, to deal with. Y squared plus 2 over y minus x over y equals 3. With y in the denominator of both terms on the left, we multiply both sides of the equation by y and get y squared plus 2 minus x equals 3y. So y squared minus 3y plus 2 equals x. This gives us a solution for x in terms of y, but it is not on the list of possible answers. However, if we factor the polynomial, we get y minus 1 times y minus 2 equals x, and that is on the list. At the end of the problem, the key was our ability to factor the quadratic expression y squared minus 3y plus 2. So the correct answer is B. Problem. If x plus 1 times 6x minus 2 times x minus 3 equals 0, and x times 9 minus 3x times 4x plus 12 equals 0, what is x? And here are some possible answers. Let's find the solution. In the first equation, x plus 1 times 6x minus 2 times x minus 3 equals 0, each of the three factors could be 0, since the product of all three is 0. Thus, from the first equation, we have these possible values for x. X equals minus 1, x equals 1/3, and x equals 3. The second equation, x times 9 minus 3x times 4x plus 12 equals 0, also has three factors, each of which could be 0. This gives us three possibilities for x. X equals 0, x equals 3, and x equals minus 3. Since x has to satisfy both of these equations, and the only value for x that satisfies both of them is 3, then the answer is 3. So the correct answer is E. Problem. For which of the following polynomials is 2 plus the square root of 3 a root? And here are some possible answers. Let's find the solution. The root, 2 plus the square root of 3, looks like it came from using the quadratic formula. So if we plug the coefficients of each of the polynomials in the list of answers into the quadratic formula, we should see which one has 2 plus the square root of 3 as a root. The formula for the roots of the polynomial ax squared plus bx plus c is minus b plus or minus the square root of b squared minus 4ac over 2a. Let's try this formula, or a portion of it, on each of these polynomials. Since the square root of 3 is part of the root, then we need to look at the part of the formula under the radical, the square root of b squared minus 4ac, and see if the square root of 3 can result from it. Answer A. Minus x squared plus 4x minus 3. b squared minus 4ac equals 16 minus 12, which equals 4. Answer B. X squared minus 4x plus 3. b squared minus 4ac equals 16 minus 12, which equals 4. Since 4 is a perfect square, the square root of 3 will not be part of the root, so neither of these polynomials is the one we're looking for. Answer C. Minus x squared plus 4x minus 1. b squared minus 4ac equals 16 minus 4, which equals 12. Since the square root of 12 equals 2 times the square root of 3, this polynomial looks like a candidate. So let's work out the full formula. Minus b plus or minus the square root of b squared minus 4ac over 2a equals minus 4 plus or minus 2 times the square root of 3 over minus 2. And that equals 2 plus or minus the square root of 3, which yields two roots, one using the plus sign and one using the minus. One of these is 2 minus the square root of 3. And since this is equal to 2 plus the square root of 3, answer C is the correct polynomial. To make sure, let's look at the other two answers. Answer D. X squared minus 2x minus 3. b squared minus 4ac equals 4 plus 12, which equals 16. Since 16 is a perfect square, the square root of 3 is not part of the answer, so this polynomial doesn't work. Answer E. Minus x squared plus 2x plus 1. b squared minus 4ac equals 4 plus 4, which equals 8. Since the square root of 8 equals 2 times the square root of 2, the square root of 3 is not part of the answer, and this polynomial fails also. So the correct answer is C. Problem. X plus 3 over x plus 2 equals 0 has how many real roots? And here are some possible answers. Let's find the solution. When we remove x from the denominator of one of the terms in this equation, we will see that we have a quadratic equation. We do this by multiplying both sides of the equation by x. X plus 3 over x plus 2 equals 0. So x squared plus 3 plus 2x equals 0. Rearranging the terms, we get x squared plus 2x plus 3 equals 0. This equation won't factor easily, so we use the quadratic formula. However, the question is merely asking for the number of real roots the equation has. Therefore, we only need to check as to whether the expression under the radical in the quadratic formula, b squared minus 4ac, is positive, negative, or 0. If it's positive, then the number of real roots is 2. If it's 0, then the number of real roots is 1. And if it's negative, then the number of real roots is 0. So let's calculate b squared minus 4ac. b squared minus 4ac equals 2 squared minus 4 times 1 times 3, which equals 4 minus 12, and that equals minus 8. Since b squared minus 4ac is negative, the equation has no real roots. So the correct answer is A. For more practice GMAT problems, see our other videos and go to www.gmatmath.online. And you can get our ebooks, GMAT Math Basics, GMAT Math Problem Solving, and GMAT Math Data Sufficiency. Thanks for your interest.